Rahman Rahim. Respected teacher, Assalamu alaikum. My name is Murad Ali Khan, student of Civil Engineering, UT Peshawar. Our final year project presentation is Seismic Risk Assessment of Educational Building and District SWAT. Our supervisor are Professor Dr. Shahidullah Sahib. My group members are Muhammad Ali, Muhammad Aziz Khan, and Muhammad Arif. Now, I will some review our presentation contain these topics: introduction, problem statement, aims and objective, methodology, and references. First of all, I have some brief introduction. Pakistan is one of the most seismically active region in the world, and the earthquake of October 8, 2005, Kashmir, and a significant damage to the infrastructure and the human losses. Before this earthquake, Pakistan is not its own building code. In 2007, after the Kashmir earthquake, the first version of building code of Pakistan was developed, where most of the northern areas of Pakistan was showing that the hazard are more than 0.24 G of P ground acceleration, corresponding to 10% probability of the accidents in the next 50 years. In building code of Pakistan's the seismic project 2007, Pakistan has been divided into the 5 seismic regions: Zone 1, Zone 2A, Zone 2B, Zone 3, and Zone 4. As our area of interest is District Swat, so according to the building code of Pakistan, District Swat is situated in the Zone 3. This area can have P ground acceleration value of 0.3 G. The yellow in the seismic in this seismic map of Pakistan, the brownish yellow color represents the Zone 3, in which the SWAT is situated in the Zone 3. Here, the Mingara, which is the main city of the SWAT, is looking in the Zone 3 region. Yes. What is seismic risk assessment? Actually, it is the process to estimate likelihood of building and infrastructure damage and economic loss due to the seismic hazard. The process enables us to know that the region which are the vulnerable and likely and having higher likelihood of damage and loss because of the potential earthquake in the future. This way we can prepare ourselves to mitigate the future losses and better equip the rescue and relief institute. Seismic risk analysis is a typical job considering its input and parameters. So here are the 3 main parameters are required to carry out the seismic risk assessment. These are seismic hazard, seismic exposure, and seismic vulnerability. So what is the hazard? Hazard is anything which is the harmful to the human and buildings or infrastructure. Seismic hazard, the effect of the future earthquake on the humans or the building in the environment is called seismic hazard. The effect of the earthquake or the ground shaking, ground rupture, landsliding, and soil liquefaction. Seismic exposure, it is defined as the worth and location of the building which is exposed to the future earthquakes. And seismic vulnerability, it is defined as the likelihood of the damage of the building due to the certain ground shaking and the future earthquake. Now I invite my groupmate Muhammad Aziz to continue the presentation.
Assalamu alaikum. My name is Muhammad Aziz Khan. I will discuss about the problem statement of this research. So as we know that the district Swat is placed in Zone 3 of Building Code of Pakistan, so it can experience peak ground acceleration value of 0.3 G. As we know that there is a high seismic zone. So from the past earthquake, we see that the education buildings experience very much losses of human and infrastructure. So keeping all this fact in mind, it is necessary to estimate the seismic risk of educational buildings in Swat. So the aims and objectives of this research are to know the building class of educational building in district Swat and to estimate the damage ratio and financial losses of educational buildings in district Swat. So in methodology, we will follow 5 main steps. First is the using of OpenQuake engine. Second, we will be doing hazard assessment. then we will be doing creating an exposure model, then we will doing vulnerability model, then the last we will do risk assessment. So using OpenQuake engine, OpenQuake engine can be operated by two windows. One is the OpenQuake through console and other is the OpenQuake through web user interface. So what is the console? In console window we do programmings and we do programmings and get the results. This programming is done in the form of Python language. So we will do some program and then we take the result. Next slide. These are the programs and result. This is the result and that is the program. So next. This is the OpenQuake engine web user interface. In this web user interface, this operates on zip file. This zip file is fully loaded with each and every information and values. So this can also be related with QGIS software through a plugin that has named OpenQuake IRMP, Integrated Risk Management Toolkit. So next. These are the result of the process which we have done in OpenQuake, and these are the result on QGIS. So now I will invite Mr. Muhammad Arif for further presentation. Thank you.
Thank you, Muhammad Aziz Khan. Now I will be continuing the hazard analysis. As already discussed, risk assessment is the product of hazard analysis, exposure model, and vulnerability. So for the hazard analysis, there are two popular methods available: deterministic hazard assessment and probabilistic. So specifically speaking for the OpenQuake, here we will be using probabilistic hazard analysis. Next. As for the exposure model is the tough task in risk assessment of educational buildings. Like in this type, we need to know about the different types of the buildings, their location, longitudes, and latitudes. So from this, we will get an idea like how much exposed is this specific type of building to the natural hazard that will be occurring in future or in the present times. Regarding this, our supervisor, Dr. Shahidullah Sahab, is already provided us data regarding this. So we will be only working on the analysis and assessment part. As for the vulnerability, we already knew that we will be checking that what type of buildings are located in this specific district, like district SWAT, like they are brick masonry or stone masonry or reinforced concrete. So regarding this, we will be using a model technique from GLOSI, Global Library of School Infrastructure, given by UN. So regarding this, first of all, we will be collecting all the information, all the data which is required for the risk assessment. Then we will switch, we will compare our models with the already present catalogs. Here they mentioned that you have to use the ORA analysis, like you have to design and then you have to do all the pushover analysis and seismic analysis. But it's too much time consuming, so we will be using already prepared catalogs for the South Asian countries like Pakistan, India, or Nepal. We can use any one of it, like they are almost having same type of buildings. Yes. So here is an example. If we have a reinforced concrete building with masonry infill walls, and it's 2 or 3 story building, we already knew it is designed by engineer, having small columns and beams, like it's not SMRF structure. So we can classify it in taxonomy of RC2 male drives with low seismic design. There is the schematic diagram, like we will be collecting all the data as for GLOSI, then we will be comparing it with catalogs present, and then we will get at the end the fragility and vulnerability curves. And if we want to reduce the vulnerability, so we can reduce it. They are already prepared each and everything. So at the end, risk assessment will be the product of all of these, which will be mainly doing with the help of OpenQuake engine. Next. So this is the Gantt chart for the working schedule of ours. These are the references.